Hello, everyone, and welcome to the Science Center's PD session for you today. We are very excited to have you join us, and we are going to be talking a lot about inquiry. We're going to be talking about we're going to be doing some experiments today. There is going to be a lot in this workshop or in this little session today. Before we begin, I'd like to introduce myself. My name is Simon. I'm one of the science educators here at the Ontario Science Center. And I'm just going to point beside me. Julie is beside me, so let's go from there.
Hi, everyone. I'm Julie. I'm an educator at Science Center. I've had the pleasure of being here for 4 years, seconded from TDSB. And I'm also a science teacher. So I've been teaching in TDSB as well.
My name is Tasha. I am a new teacher to the Science Center Science School and seconded from TDSB as well. And I'm teaching physics here at the Science Center.
Welcome all, I am Martin. I'm a science educator here, and I've done many of these sessions with Michelle and Oisy, but in person, this is our first virtual PD day. So welcome.
We would like to begin with a land acknowledgement. The Ontario Science Center acknowledges that we're on traditional territories of many nations, including the Mississaugas of the Credit, the Chippewa, and other Anishinaabe nations, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nation, Inuit, and Métis people. We are settlers here on Turtle Island. In the spirit of truth and reconciliation, we commit to respect, listen, learn, and support Indigenous people with whom we share this land with and who have cared for this land since time immemorial. So everyone, welcome yet again to this session. What we're going to ask is, throughout the session, we're going to ask for some of your inputs in this case, and we would like you to share this in the chat today. And throughout the chats, throughout the session, Julie is going to be monitoring the chat, and I'll be monitoring the chat later on. And I just want to show you a little bit about the session and the agenda today and what we're going to be kind of going through. A little bit of introduction, that's what we're kind of in right now. I'll show you what the links are in today's program in just a moment. And these links will definitely help us with engaging with you today and throughout our session, and also through our breakout session too. So give you a little time to get into that when we show you the links. We're going to go through a What's Your Inquiry Grade 5 program. So we're all going to do that program together. And then we're also going to do a little bit of a highlights of the 3 to 8 program and what we kind of do throughout those What's Your Inquiry programs. What's Your Inquiry is a new virtual program that we've developed for online this year. And we've got a lot of learnings, and we are going to share a lot of these with you. So I'm going to be putting on my presenter hat sometimes, and then also I'm going to pull off my presenter hat and put on my educator hat just to talk to you about how we structured this type of program. We're then going to get Julie and Tasha to talk a little bit about inquiry within the classroom, how to apply some of the things that we did in What's Your Inquiry into your own classroom setting. We're going to do a breakout room so that you can all do that together. And then we're going to do a little big share with our own, with this group here today too. Hopefully at the end we can consolidate and have some questions from all of you there too. Julie is going to share the bit.ly into the chat.
So everyone's got the link in the chat already, and I can see that we already have about 14 folks in the document. So I think we're good to go.
So everyone, what we're going to do right now is we're going to do a quick What's Your Inquiry in Grade 5. So we're going to deliver this program to you. So I want everyone to put on your Grade 5 hats right now. Just put yourself in the student's seat and think about what the students might be thinking about, what they might change in the program. And in this What's Your Inquiry program, Grade 5 students, we're going to be talking a little bit about chemical and physical changes. Now, throughout this, if you have any questions, please type that into the chat. And also, what I want you to also think about is how we can make this experiment better. Because in this program, we are not going to only do the experiment here at the Ontario Science Center, but we are going to be doing experiments at home too. So you are going to be taking an experiment and then making it your own and changing it however you want it to change. So first things first is give me a thumbs up in the chat if you have seen this pre-activity or have done this pre-activity, or give me a thumbs up reaction if you have, because this might have been sent to you through a teacher. If you can't do in the bit.ly, you can also see the document will have this handout in there. So the link is in the handout. Is there anyone that has done this? Maybe Julie, has there been anything in the chat?
Don't see any thumbs up, but I'm just going to take a bigger view to see if anyone's used their thumbs up reaction. Don't see
You know what?
many. Yeah.
That is absolutely fine, because inside of this one, we have a very easy experiment to do. And we're going to actually do it live right now. We're going to use a little bit of ketchup. So our first star is a condiment. I know most of you are thinking, how am I going to do some chemistry with some condiments? So I'm going to put the condiment onto my tray right over here. This is a little bit, a lot of ketchup right over here. What in the experiment, what we asked the students to do, or what we ask you to do, is to put a little bit of a chemical that is called baking soda on top of this ketchup. Now, before I sprinkle the baking soda and mix it into this ketchup, I want you to type into the chat, tell me any of your predictions. What do you think will happen when I mix the baking soda into the ketchup? What do you think is going to happen? So type into the chat right now, and Julie, let me know what people are thinking. So a little bit of baking soda there. Oh, all right. I think I already see some in the chat, some foaming. What will happen to baking soda and ketchup? Thank you very much for your responses. All
Lots
right.
of bubbles, Simon. Lots of ideas about foaming and bubbles.
Lots of ideas of foaming and bubbles. So maybe some of you might have seen this before, but if I sprinkle some baking soda all around it, nothing seems to be happening right now. But if I move it around a little bit, I'm going to use a little Q-tip. You can find this at home also. And I move this around and I stir it all around, and you can already see, yes, you are absolutely right. It is foaming and there are some bubbles all over the place. You can see the bubble on the Q-tip right over here. So there's something happening even in this experiment using ketchup. So you can maybe think of, what else do you think you can put on ketchup that would cause this reaction to? And then looking at the ingredients, what in the ingredient will cause this reaction with baking soda? So maybe next time when you're looking at your ketchup bottle, you can look at the ingredients. Which one of those do you think will cause this reaction? So I'm going to put this down right now. That is fantastic, because we're going to go on to another thing, is what are some of the things we observed here? So there are physical and there's some chemical changes. In physical changes in chemistry, you look at the changes and the substance actually remains the same. The changes that you might see are in the shape of it and maybe in the form, as in maybe a change in matter. So a good example for that is water. When you put it in the freezer, it turns into ice, a solid. And then when you boil water, it turns into steam. Those are really good physical changes. But then chemical changes, you have something new formed, something new that is created there. So in this case right over here, you see the bubbling here. There are some bubbles. That means there's some gas coming out of this. And that is definitely a chemical change, a chemical reaction right there. Now, I am going to take off my my presenter hat. I'm going to put on my educator hat. I just want to talk to you a little bit about what's this pre-program activity and why we put a pre-program activity into a program like this. And it is to scaffold the ideas of the program. So give a little bit of ideas of, yes, we're going to be talking about chemical and physical changes, and ask the students to already join us in this increased structure. Ask them about to make them predictions. And already inside of the handout, you'll also see for the teacher, there will be some prompts in there to help guide the students to how to ask the question and what are some of the predictions, and maybe think about what other questions you can ask to change this experiment. We also focused a lot on accessibility. We want the experiments to be as accessible as possible. Things like ketchup and condiments that you can maybe find within the household, you can do as a virtual program, a virtual experiment with the students. And then also providing something that will spark the inquiry within class. This program, we're going to be talking about ketchup, or we're going to be talking about some type of reaction. Those are some fantastic things to think about. So putting back on my my presenter hat, and I today I had my lab coat nicely pressed this morning, so fantastic. My lunch this morning though was not necessarily the best. I had my salad in the container, but look at that. my container leaked, my salad went all over my lab coat. Finally pressed, oh my goodness, what is happening here? So I already have a problem here. I want to get the stain off my lab coat. Now, when we first talk about like testing something, oh yeah, red cabbage salad. Ooh, I know, some of you might not like it, but it's delicious right over here. And some of you might notice, I can maybe test on the lab coat, but you know what? I shouldn't test on my actual product. I should learn about what I'm testing first. So I'm going to show you right over here. I have a little cutout of the same material, the polyester that I was using, that is part of my lab coat. And I put a bunch of my lunch on there. Yes, my beautiful lunch. It smells like a wonderful salad now. I want to figure out how can I fix this? How can I, maybe I can apply some of that chemical change, maybe a physical change. I have some chemicals right over here. So I have some vinegar and I have a baking soda right over here. So first of all, I'm going to see if I can maybe test it on this this test bed right over here of a part of my lab coat. So let's see. I'm using this polymer material with the cabbage. I'm going to use a little bit of vinegar. I want you to type in the chat to tell me, what do you predict? What do you think will happen? Do you think I will clean it? What do you predict? So type into the chat right now. And let's also do a little observation too. Let's observe. All right.
Some are predicting color change, Simon.
Oh, color change. You know what? Yeah. So that's definitely a great color change. I don't know if there is right now. That didn't really clean my my lab coats. That wouldn't clean my lab coats. So let's maybe use a little bit of baking soda with water. Perfect. So I'm going to use a little baking soda with water right over here. And let's brush on to the other side. All right. Okay, that's did not help at all. Oh my goodness. That is not going to clean my lab coat at all. So I definitely do have a problem, everyone. Lab coat not cleaned, and I tried using chemicals today, and it didn't work. But you know what? Another thing that we can try is some type of physical change. So we can try adding some type of physical change here. And the physical change in this case is hopefully we can dissolve some of those things inside of that fabric so that it can get removed from our fabric. Let's see if this works. So I'm going to put my water right over here in front of the camera. I'm going to take my wonderful piece right over here, my test piece, and then I'm going to dip it right in. Let's see. All right. So already, do you see in the water something is starting to happen? You can see the chunks of cabbage all out there, and I'm moving and swashing around. And then all I can do is, let me just show you. Right there, I have a white piece of cloth again. And that is all by just using a little bit of water and some physical change. That is fantastic. So looking at this right over here, we can use these ideas to maybe clean something else. What do you think? Do you think you would be able to maybe clean something else utilizing some physical and chemical changes? Yeah, grade 5 students, you're absolutely right. We can definitely use this. And now I'm going to just take off my presenter hat, everyone. And I just want to talk to you a little bit about our increased sparking demonstration. So we want some disruptive events. We want to show things that are fantastic before we even go into an inquiry experiment. So here we could generate a narrative. We create almost like a story. And it is a way to introduce acids and bases and even chemical reactions within this one demonstration. But we also start the students off with some observational skills and also an experiment to spark that inquiry and those questions that they might have already in their heads. To scaffold this inquiry process, we want to model a lot of the inquiry process too. So asking those questions: what do you think will happen? What are some of your predictions? What would happen if I change this? What would happen if I do a chemical or maybe a physical change? What is going to be different? This is a good way to set the students up for success and also provide some science content even before jumping into an inquiry process. Educator hat off, presenter hat back on. All right, take a look, everyone. We are looking at this as an everyday connection. Yes, we do laundry every day. Maybe, actually, you know what? Hands up. Do you all grade 5 students do your laundry every day? You know what? That is fantastic. Some of you might. And going through how a laundry machine works will actually help us through our process today too. Looking at a laundry machine, you need a lot of water. You need to do a little bit of dissolving, like what I was doing before. What about some scrubbing? So me moving my hand inside the water, scrubbing, moving, and emulsifying. And then also there's some reactions that happen within our laundry machines or our washing machines too, to help us with getting our clothes nice and tidy. Now today, what we're going to do is, I know we're talking a lot about how we can clean things, but I have a challenge for you today. My challenge for you today is to do it yourself. How can you remove a stain yourself? Do it yourself and make some changes. So today's challenge is your DIY stain removal. Do it yourself stain removal. Now, I know you're looking at that upholstery. Not all the times it's in upholstery or in your lab coat. Maybe it's in the seat of the car, or maybe when you're having dinner on the couch and you're watching the game and you have pizza and pizza drops all over the couch. There are many different things where you can actually use this also. And this is in your daily life. I do have a question for everyone though. This is a big question. What is the best method to remove a stain? Is it a physical change? Is it a chemical change? Or do you think applying both of them would help you remove a stain better? So if you can type that into the chat, that would be fantastic. So I see a lot of you are typing in and say both, or I see a lot of C's. That is fantastic. You know what? That is an amazing thing, because what we're going to do, I love this, these wonderful predictions, because what we're going to do is we're going to do this ourselves. We're going to try this ourselves in an activity. And right now, what we're going to do is, if you can gather all your materials, some of you might have already seen this activity. Julie, I believe you already put it inside the chat also. So if you haven't joined us yet inside of the activity, please take a look at the handout. And in the handout, we ask you to have a couple of materials. So I'm going to pull out my cart right over here. A couple of materials. We're going to start off with one very easy stain. Since we've been using ketchup, we're going to use ketchup today for the first one. And then also a little bit of vinegar, maybe some baking soda, some water would be perfect to have a little bit of water. And then also some fabric too. So if you have some fabric, you can cut them into threes, and then you'll have 3 squares of fabric. If you don't have the fabric, that is absolutely fine, because you can use a little bit of paper towel too. So you can even try with a little piece of paper towel this cleaning method. So I'm gonna give you a couple of seconds to go and grab your materials as we go, because what we're going to do first, and we're gonna do the fun thing first, is we're gonna make a stain. And most of your parents are thinking, no, stop, you can't make stains, right? That's a lot of work, but you know what? Today we are going to clean things ourselves, so that means you can make as much stains as you want, as you can make it as dirty as you want. So for our first stain, yes, we're going to use ketchup, and I think most of you, hopefully most of you already have 3 pieces of either a paper towel or a cloth, because we're going to go through some of this process right now. So first thing, make sure your light color rag or paper towel, or even anything that you can find around you. It could be a sock, an old sock. What I want you to do is just to label them on the top as cloth 1, cloth 2, cloth 3, or you can just do 1, 2, and 3. I'll give you a couple seconds to do that. And as we go, I am going to start to think about my stain. So I don't want to make too big of a stain right now. I want to, put a little bit of ketchup on top of my cloth. So I'm going to actually start to do this. For the folks that are still following, you can use the handout if we have skipped past where you are at, or you can also, if you're way past me right now, you can continue on in the process. So I have multiple people involved in this process, in this program, so I want to make sure that everyone is following along in a certain way. All right, so I have gotten the droplets of ketchup on there. What I want you to do is you can spread the droplet all over the place on your cloth. So I'm just going to spread it all around. You can use your finger. I have asked for in the document to ask for some Q-tips. So if you have some Q-tips available, that would be perfect too. So I'm going to use my Q-tip. I'm going to wipe around this area right over here. And I'm going to do the last one right there too. So there we go. There is your ketchup stain right there. I have 3 stains all in a row. And for the folks, if you want to, you can utilize anything, any other material. If you don't have ketchup also, you can find another thing to stain with if you want to do that too. So we're going to move on. What we're going to do is we are going to dip our cotton swab, or you can just pour a little bit of the solution. We have both vinegar and baking soda today. So you can pick either between vinegar or baking soda, whichever one you want, to figure which one you want to clean with. So I want you to think back at our pre-activity today. Our pre-activity, ketchup had something that really reacted well with vinegar? No, with baking soda, right? So with baking soda, yes, we can maybe use a little bit of this. So that is pre-existing knowledge right there. And then also, if you have water, the first one is just using water. So if you can dip your Q-tip inside of some water and then just move it around like this, see if you can clean that area with just using water. So I have this Q-tip. Maybe I'll dip it in a little bit more water right over here. And then I'm just going to rub that in. I think I made it look a little worse actually right over here. Not that great. How about let's try a little bit of baking soda. So I'm going to try a little baking soda onto, so I'm going to do a little sprinkle of it. So a little sprinkle of it of baking soda on top. This right over here. I'm just going to sprinkle a little bit right on top. All right, so baking soda in. All right, let's see the Q-tip, and let's move it around. So there is some type of reaction happening. That's great, but does it remove any of my stains? You know what? I think it got a little better. Let's see, let's compare our control versus our experiment here. So the water will be our control today, and then this one will be our experiment. Doesn't look like there's many changes. So most of you are thinking, what do I do with the third one? The third one is going to be all you. What can you do to change your experiment? What can you change? What's one thing that you can change to make it different? Try it and compare it to cloth number 1 and 2. And for today, what I want you to do is to share it with us. Share with us what your experiment looks like. And this is based off of Padlet. So we have a Padlet link right at the bottom. It should be in the chat and also in the document that you have there too. So everyone, go join the Padlet, and I'm going to give you a few minutes to go ahead and start your experiment right now. Think of the one thing that you're going to change. I want you to continue working on, is it doing with the water and also the baking soda or vinegar? Start with those ones first, those simple experiments first. You can take a photo of them and post it on the Padlet. And then think about ways that you can change the experiment for your third cloth right there. All right, now it's time for me to pull off my presenter hat again. We're going to go into our educator hat right here. Picking the right experiment. And this is actually really important throughout our inquiry process, our inquiry experiment process. How do we pick the right experiment? And we actually would start right off at the curriculum and looking at the curriculum and extracting one big idea from one strand and focusing on that one big idea. In this one, we were looking at physical and chemical changes. A way to utilize physical and chemical changes is looking at everyday life, looking at laundry. There's many different ways to actually apply physical and chemical changes. But we're trying to find the experiments that give you when we take the big ideas, we can break them down into its basic concepts. Basic concepts of doing laundry. What are some of those concepts? You need to dissolve your stain. You need to have some chemical reaction. What happens when you put bleach in there? What do detergents actually do? What is that process? And breaking those processes down and really looking at it in a bigger picture. Now, working with accessibility in mind is always looking and thinking about the materials that you can use within classrooms, and also looking at materials that you might not have in classrooms, at home. How do we do this virtually? How do we do this if you don't have a fridge in the class? How can you change it and adapt it to make this experiment right for you. And that's a really big part about picking the experiment. All right, I'm going to take off my educator hat, putting back on my presenter hat, right over here. I just want to ask everyone about one thing that you would change. What are the things that you would change? What are some of the variables that you would change in your experiment? What's that one thing? And then what is one thing that you would observe and measure in your experiment? So I have some ideas that are coming down to Padlet. Julie?
Yeah, I see some ideas coming into the Padlet, some talking about the method of cleaning. So not just the materials, but the process you use. So blotting versus scrubbing. Some are talking about temperature. So how hot or cold the materials you're using might be. And I see some ideas just starting to come in. So folks, feel free to add more ideas for number 3 for how you might measure the effect. Simon is focused on color so far, but there might be other ways you can come up with that you would use to measure how well your method works on the stain.
That is exactly right. So those are fantastic. Temperature is a great one that you can test with, cold or hot. Why do we soak things in cold water, or why do we use hot water? Those are many different things to really inquire about. Now, looking at this, we're going to try to make a testable question. So we choose one thing to change and one thing to observe, and we create a little question for it. So if I change the material, let's just say of the cloth, what will happen to the diameter of the stain? Is there anything that would change? So that is a really good question. So looking at the questions that you create using the one thing that you change and one thing you observe, we can make your own prediction. So in this one, if I change the material, the diameter of the stain will shrink because, maybe because the material, let's just say if it's a cotton versus a polyester, maybe cotton is really good at absorbing some of those stains. Maybe the polyester is not as good. What about wool? What about all these other different materials that you can use in your stains, so in your stain experiment? So think about it that way, is how can I change my experiment to make it, it's fairly similar, but make it my own experiment too. Can we design a fair test? So how many things can you change at once? Can I change in my experiment? Can I change the cloth and the stain and the procedure and how I do it? That doesn't seem like a very fair test to me. So look at the control right over here. This is my water control in comparison to my baking soda. I just added baking soda in comparison. But what if I were to change it to, instead of scrubbing, into blotting? Or maybe instead of scrubbing, into soaking? What would happen? What would be different? All these different opportunities to create a fair test. So think about your control and change it based off your control. All right, so hats, switching hats again. Why did we do this structure here at the Science Center? Over these past few months delivering these virtual programs, the structure is built like this so that we can kind of help scaffold this inquiry process throughout the program and also before and after the program too. So there is the pre-activity, there's some inquiry discrepant events based experiments that we deliver here at the Science Center. We have the very simple experiments that can go that can change really quickly and really drastically based off of what the students want to change in their experiments. There's a post visits take it further part that we give the teacher too, so help scaffold the rest of the inquiry process. And that's kind of why we kind of scaffolded this way. We wanted to start very level 1 and then kind of move up on the way too. So we can also guide the students towards a more cause and effect relationship in an experiment. What would happen when you change one thing? And you can kind of see the one effect that happens right away. So this one, not much of a change, but what if you change the fabric? It changes the experiment right away. You can see quite the difference at that point. And then looking at and giving the students an opportunity to drive their own experiment. This is a great opportunity for the students to really think about their own experiment. What can I do and how can I test this is what we want to give the students. What can they do. All right, so looking at our experiments, that was one out of 6 experiments that we do in What's Your Inquiry. We range from a grade 3 to grade 8 program. And in grade 3, the grade 3 one is very simple, using just paper and tape. And paper and tape, building columns and testing those columns out. And we found a lot of success in this. So you can, if you look at this one right over here, the cylindrical column is way better than the triangular prism column right there. And then you have sound for grade 4. For grade 4, looking at sound, we started off with building a big instrument. That was too complicated, too many variables that happened there. And using a rubber band and just a cup, we can actually test a lot of different things. You can test materials, you can test design, you can test how loud something can be or how quiet something can be. You can test pitch and all that different objects, all those different variables. Now, looking at the grade 5 one, you just did it, and I think there might be some great opportunities for you to even try this yourselves, not only for grade 5, but moving upwards to other grades too. Julie, are there any interesting things that are coming up in the Padlet?
I've just been replying to some folks in the Padlet, which is one of the things that I love about it as an educator, is that I can have back and forth, whether synchronous or asynchronous collaboration in the Padlet. And so I saw one testable question about not changing the material. It was really interesting, but actually just leaving it for longer. So changing the length of time that you allow it to interact, which is really neat.
That's fantastic. Those are fantastic testable questions for you to all think about. And then we can also create a lot of different types of experiments just by using a few testable questions. All right, so I think most of you seeing me, I'm getting dressed up right now, and I'm going to be using some type of material in just a moment. And this is related to our grade 7 strand that we are focusing on, and it's heat in the environment. So I'm going to be geared up right now. I have some cryo gloves. But the pre-activity that we've given the teachers and the students for in class is to actually just put an ice cube on a different surface. One on a metal surface like an aluminum can, and then another on a plastic surface like this. And this is one of the pre-activities, and for the students to observe and maybe even make changes here too, to look at how heat is transferred into an ice cube. So I have another experiment that will actually do that too, and that will reflect with that too. And I'm actually putting on all my safety equipment because we are going to be using our wonderful liquid nitrogen. Now, most of you are thinking, liquid nitrogen, oh my goodness, that is so cold. Can anyone here in the chat tell me or make a guess on how cold is liquid nitrogen? All right. How cold do you think is liquid nitrogen? So you can type that into the chat right now. And as I move this, I'm going to actually pull a ladle out and point it towards the camera. And you can already see something's happening with the liquid nitrogen here. Something's actually happening. What is happening here?
I see some predictions coming in for -85, -200, -100, -150. I'm guessing these are Celsius.
That is fantastic. So those are really, really, really great guesses. And if you look at this right over here, yes, it is boiling. It is so cold. Liquid nitrogen is so cold that the atmosphere is able to boil the liquid right over here. And you can see it's so cold that the vapor, usually when you look at steam, when something's boiling, the vapor goes up. This one, the vapor is going downwards. It's so cold that it's going down. All right, so what we're going to do for this experiment is we're going to focus on material. The two materials, a styrofoam, and we're going to use a aluminum can. What we're going to do is we're going to put some liquid in there, some water, some blue water here, into our cans or into our two containers, and then I'm going to submerge them into liquid nitrogen. I want you to make a prediction right now. The prediction is, which one will the water inside the containers freeze quicker? Which one? Do you think it's going to freeze quicker in the aluminum, or do you think it's going to freeze quicker inside of the styrofoam? And as you're making your predictions, I am going to fill it up with about 15 cc's of blue liquid into both. And Julie, are there any predictions happening inside the chat right now?
You see some folks predicting aluminum and agreeing with others who chose aluminum. So far, it seems like aluminum is dominating the predictions.
Okay, yes. Now, thinking about this experiment, I have another thing that I want you to think about, is I want you to think about where does the heat come from and where is the heat going? How is the heat being transferred? And in this case, I'm going to put liquid nitrogen, 2 ladlefuls of liquid nitrogen into each of these beakers. I'm going to do one here. Let me just do one here. And then we're going to submerge the cups into the liquid nitrogen. So we're going to put it right on top, right over here in the liquid nitrogen. And then I'm going to pour this right in there. Slight little spillage. I'm going to just pour a little bit more, tiny bit more, so that we have an equal and fair test. And yes, yet again, we're using that word, fair test. I want to make sure that they're equivalent, the same amount of liquid nitrogen in there. All right, in 3, 2, 1, I am going to put our 2 cups in there, and let's see. So this is a good time for us to maybe even to keep track of time. How long have we had the liquid nitrogen, the cups inside the liquid nitrogen? Can you see the blue liquid? Yes, you can see the blue liquid. You can already even hear something starting to happen. The really fantastic thing about this is the heat is actually coming from the water. The heat is in the water. The heat is actually being transferred from the water into the liquid nitrogen. But which material does it better? Which material will be able to transfer that heat into the liquid nitrogen better? So this is the test that we're looking at. Which one will freeze quicker? So let's see if your predictions are right. I have my tray here just in case anything spills. I don't want a wet surface. So it's been a couple minutes right now. Let's see if we can show you. And there's already a big difference between the amount of liquid nitrogen. So this one actually has a lot less liquid nitrogen than this one right now. And I just want to show you the aluminum can. I think your predictions are right. You see that right there? There's a lot of ice there. Whereas this one, you see all that liquid? That is still a liquid right there. So everyone, that is fantastic. Let me just pour this one out. I just want to show you there's not much liquid on this one right over here, whereas this one right there, that is fantastic. So that is just using a liquid nitrogen to create something called a discrepant event, a really unique event to show difference between materials. As materials transfer their energy through, which one is better at heat transfer? So we're talking a little bit about heat transfer right over here. Transfer of heat goes from hot to cold. Now, we also have grade 6 and grade 8 experiments in flight. So you have a glider or a helicopter, and then a trebuchet or catapult too. So that's something that we also experiment with the students. Now, there are, of course, some successes and failures, and we're going to go through a little bit of successes and failures that we had to work through. Here are some things that worked and learning moments that we also had too. Some of our successes are some of the low floor and high ceiling experiments with high impact, and it allows students to be creative in their experiments. Successful inquiry, even within classes that did not prepare to come to the Science Center with an inquiry experiment. So maybe they booked the experiment or the program without actually preparing any of the materials. We're still able to conduct an experiment with them. Just ask the teacher, hey, grab some paper towel instead of cloth. Maybe instead of ketchup, is there anything else that you can use too? And then the inquiry experiments are accessible with many diverse learning abilities. And I just want a little quote right over here. I want to show you a little quote right over here for our grade 3 class. The program was very successful to the point where some of the weaker academic students that did not see themselves as scientists actually were able to use their creative juices to create a strong structure with their paper and also say, I'm a real scientist. And that is kind of the goal, right? That is our goal, is to be able to encourage students to become their own scientists there too. But of course, there's also some failures. In grade 6 gliders, too many variables, a lot of frustration. There's too many unknowns. And not only were students frustrated, but educators, even us, we were frustrated in building them too. So pivots and reassessing those activities are very important. We overestimated in some of the materials, such as possibly having tablets or not having tablets, or even extra computers in class. So looking back at things, it's really important to look at the accessibility of these experiments, and do we have these things in class? And then also limited time for inquiry. Inquiry needs time. Unfortunately, we have 45 minutes, and hopefully we learn from this, and we will consider to do maybe even further experiments with classes that have come to us before, and the lack of reflection. So there are many failures on our end, but also learning. So we can learn from all those for better programs in the future. Now that we've learned a little bit about how we deliver these and how we created this program, What's Your Inquiry, I want to throw it over to Julie and Tasha to talk a little bit about how to utilize this structure in class and how to build your own inquiry experiment.
Thank you so much, Simon. That was great. I always love seeing the liquid nitrogen demonstrations, one of my favorites. I know that many of you are familiar with different levels of inquiry, and using Banshee and Bells, we want to ask you a question, hoping that you're going to answer it. The first question I want you to ask is, which of the following inquiry approaches do you think gives students the most autonomy regarding the design and execution of a science experiment? Do we see answers coming in? That's great. Give people just another 5 seconds to put in their answers. 3, 2, 1. Thank you so much. These are the results. This is what it is that the class has said, that the majority of you feel that open inquiry is going to give students the most autonomy regarding that. If we look at the chart, and this is based on Banshee and Bell's steps of inquiry, confirmation inquiry, which sometimes you probably heard as the recipe lab, is where the students have very little choice over what it is that they're going to do. But as we move from the confirmation inquiry to then structured inquiry and guided inquiry, and eventually into open inquiry, what we're doing is we're increasing the amount of student choice that they have over what it is that they're going to test, and how it is that they're going to test, and what kind of answer it is that they're going to get. A really great visual for this comes from Trevor McKenzie. And the image that you see of the pool gives us an analogy of thinking about an entry point into doing inquiry for students. So if we look at confirmation inquiry over on the left-hand side, here we see that recipe lab idea. There's one design, there's one way that we're going to do it. The students are led through step by step, just like if you're learning to swim, you start at the shallow end of the pool, and it's very prescribed. As we move to structured inquiry, at this point now, the students they're looking for their own answers, but they're still recognize that the teacher is designing the question, they're designing how it is that it's going to be done or performed for the students, and then we're progressing. So we go to guided inquiry. Now the students are doing more design over how it is that they're going to execute finding their answer, whereas open inquiry, everybody's in the deep end at the pool at this point, and now the students are able to say, what is my question when we think about inquiry? How will I find out the answer to that? And so they're designing their own procedure. When we think about the type of experimentation or inquiry skills that students need in order to be able to do this, we want to ask you another poll question. And the poll question is the following. Let me just pull it up here. Right? So which type of inquiry do you think demands the more proficient experimentation skills by the students? So if we think again about those 4 levels, which ones do the students need to be more proficient with experimentation skills? This is awesome. I'm seeing so many people just getting right in there. Thank you so much. I'll give people about another 10 seconds to put their answer in. So 3, 2, 1. And here are the results that we see for the group. So most of you have selected that you feel that open inquiry is where students are going to need to have the most proficient experimentation skills. Often when we think about experimenting, we think about sort of those technical skills that students need to have, but we recognize that there's more to doing inquiry and experimentation than just the technical skills. In your curricular documents, I think this one comes from the 1 to 8 science curriculum, and this is from page 13 of that document. There's a continuum that shows us the inquiry and experimentation skills. So we recognize students, they start as a beginner, and what we want to do is we want to give them opportunities then to progress through these skills so that they become proficient. It's not just about doing titration, right? It's about initiating and planning and designing those testable questions. And what we need to do is we need to help them and support them as they do that. Thinking again, as Simon was talking about earlier, what is accessible materials for those students? When we're designing how we're going to do it, how much time do we have in order to be able to get this to do? What are our safety considerations? So we have all of these other factors that we need to think about. Sorry, I didn't mean to shade the chem folks there. It's physics. I don't know. What can I say? There is also, of course, assessment and evaluation. Julie, can you maybe just talk about that for a moment?
Yeah, so we're going to, just to give you a preface, we're going to invite you to go into a breakout room and start to think about how you can translate any given lab activity in science into a more open inquiry, maybe guided, structured, or maybe even open. But when we're going into that planning process, having worked with lots of different teachers and classes in the past and for my own practice, I know that assessment is always front of mind for me. And not only for how am I going to mark this evaluation or this experiment, but also from the perspective of what feedback, what formative assessment am I going to want to be mindful of as I'm guiding through students through the process. So as you mentioned, the open inquiry, as a lot of you polled in the poll, the open inquiry can require more proficiency in these skills. So the thinking and investigation chart that you see here is just pulled straight from your achievement chart in the grade 1 to 8 science curriculum, and a similar chart exists in the secondary document as well. And so this is page 26. When you're trying to think of assessment criteria and try to identify which things might I want to give feedback on as a teacher or peer feedback, or which things might my students be ready to be evaluated on as an assessment of learning, these have all the criteria that you might incorporate as you're planning. And so really good to keep front of mind, and it's already embedded right within our curriculum documents, and it looks really similar in the secondary document. So we're going to invite you to go into some planning. So I'm just going to show you a little tour of what that process is going to look like as a suggestion for how you could find these opportunities for more student choice and voice just by tweaking or adjusting things that you already have. So I'm going to put a link in the chat. I know somebody mentioned in the chat that they joined recently, and in a moment I'll put a message to the main links document. The one that I've just posted is just the workspace chart that you see a screenshot of here. So I'm going to open it on my device as well and show you what that workspace looks like. So what we're inviting you to do in this breakout is to think about how to tweak an existing lab. So in your breakout team, you'll find the workspace that goes along with whatever breakout room you end up in. So if you're in group 1, you'll click this link for group 1. And just as a side note, modeling different strategies that I love to use, a collaborative class slide deck with each group having their own page for me as an educator is really awesome because I can go into grid view and keep an eye on what everyone is doing and have a sense of how far along they are, which is just a great tool for me. So when you're using this doc, what we'd like you to do as a team is to pick a recipe-based experiment. So we've given you 4 to consider: build a water filter, build a pulley, build a lever, or build a lemon battery. So in your team, choose one of those recipe-based experiments to start out with. Then next, as a team, decide, well, what kind of inquiry do we want to tweak this to? Our sense from looking at these, and most of these are already designed as a confirmation inquiry. They have very clear steps and tell students exactly what to figure out. So as a team, decide, do we want to try and tweak that to turn it into structured, guided, or open? And you'll do that using your work template. So each team will have a similar template that you see here. I'm going to go out of present mode and just show you when you're in that template, you'll see some prompts and some guides in the speaker notes below, just to give you some things to think about. And what we first want you to prioritize is to think about how can you tweak this to give more student choice and voice, give them more power in the process. What decisions would you let them make? Are they going to measure? Are they going to decide what to measure, what to change? Are they going to build a testable question? And in order to be successful, what scaffolding or supports or coaching might you need to provide in the process? And if some of you have ever used Jamboard before, we're also modeling that, sort of mimicking that tool. We've got some sticky notes over on the side. If you like, you can use those. You can use text boxes for different group members to contribute to the same workspace. If time allows, and you've already started unpacking how to restructure that recipe-based lab, you can start to think about, if you have time, what kinds of materials would be more accessible to a broad group of students. Are there any safety concerns that you might consider? And then lastly, if you get to it, you can think about that achievement chart for thinking and investigation that I just showed, and think about, well, what criteria might you assess? Are there any accommodations or scaffolding you'd provide for different types of learners? All right. So you'll find this again in the link I just posted in the chat. Everyone is going to be in the same slide deck, but find the group number that goes with your the room that you end up in. All right. So I'm just going to open the breakouts. And you'll have about 10 minutes. And as a heads up, when you come back from the breakouts, you're going to get an opportunity to share and reflect on the way that you reframed it. All right. I'm just double checking that there's more than one person in each of our breakout rooms. Some of you might be in a bigger or a smaller group. I'm just going to move a couple of people just to reshuffle the rooms. All right, here we go. So you should have about 10 minutes to take some time. The recording, just as a heads up, won't record the discussion and the dialogue as you're planning in your breakout room. Welcome back, everyone.
I think we're all back in.
Yep.
All right. I hope you had a great discussion while you were in there. Just based on the activities that people chose, we're going to stay in the main room for this sharing discussion that's going to happen. And what we want to do is we want to hopefully hear from people who have chosen different types of inquiry. So we want to hear from structured, and we want to hear from guided, and we want to hear from open inquiry. And if you would be able to share part of the discussion of what were the challenges that you had for the different types of inquiries, or what you could foresee would be challenges, and then what kinds of supports it is that you would think as teachers you'd need to be thinking about for students to be able to do that kind of inquiry. Julie, can I give it to you? I think you're muted.
Thank you. I was just editing there, folks. I'm wondering, for folks that chose open, I know that we saw a few teams chose pulleys, and then one team chose lemon battery. For the folks that chose open, how did it affect the type of decisions? Like, what type of decision making, if anyone wants to share in the chat? All those different factors, like what materials you might provide in choice for them to choose from different materials, and how you would how much control you would give them, as well as someone mentioned, how to hook them. Another thing to consider, we gave you recipe-based experiments because we wanted to just point out that you don't need to build this from scratch, this type of project or experience for students. So looking for existing activities and then just how you can tweak them or reframe them can be a really powerful and easily accessible tool for educators, but also within your curriculum. So on the slide that I'm sharing here, when you look into any strand in any grade in your curriculum, for 1 to 8, they're always framed the same way. They're either going to say, like this one does for pulleys and gears, use scientific inquiry and experimentation experimentation skills. So those are always going to have lots of ideas and opportunities for which types will fit well within the strand. There'll often be an expectation that also says use technological problem solving, which will be more around engineering design. And then in the secondary curriculum, in the same section, in that section 2, you're going to see those opportunities for student designed experiments and the same continuum of skills that helps you figure out what skills they're going to build and support. Tasha, was there anything you wanted to add before I pass the torch back to Simon?
Part of the framing, I think, too, in my own experience when I'm working with inquiry, I know inquiry is really happening when I start to feel like the lab assistant in my classroom. And I love that shift where they are telling me what it is that they need to do, they need to have in order to execute what it is that they've done. And when I have released that control, that makes me so happy, because that's when creativity ends up coming forward. And so it's that shift. I'm not in charge, they are. It's a wonderful feeling in secondary for sure.
Thank you, Tasha. I'm going to pass the torch back to Simon and Martin just to think back to how some of the ideas around scaffolding connect back to the What's Your Inquiry program we saw earlier.
Yeah, so with the What's Your Inquiry program that we've developed this year, and it's been done virtually, it's a great place to begin and also continue on with that inquiry process. We kind of start you off at a beginner level, and then we kind of scaffold your way through towards an more open-ended inquiry process. And the best thing about working here and having a great team such as Julie and Tasha and Martin is that we can bump ideas off each other. Is this accessible? Is this inquiry accessible? What can we do to further the students' inquiry in this process? Are all the questions that we usually ask before we even create a program and create an experiment. With the discrepant events, we are super lucky with having the chemicals and the liquid nitrogen and all those wonderful things that we have here at the Science Center. But it's not only here. You can do this in your classroom too. Just like I believe one of you were saying before, is that you can take one of these lab activities and make them into a demo. And then that helps spark the next conversation towards inquiry also. So those are fantastic ways to incorporate this into class. And hopefully the structure also helps you out with creating your own inquiry in your lesson plans too. So a way for you to inject, maybe it's not open inquiry, it could be guided or structured, just a way to incorporate this into your lessons.
I think maybe to add on to that too, Simon, having gotten trained to deliver school programs to visiting classes myself, and also having the lens like Tasha of a teacher as well and a classroom educator, one of the things I've found is most powerful about this and other Science Center programs is that collaborative planning between teacher and Science Center. So it's not a show that the Science Center is putting on for your class. And because there's those pre and post follow-up resources, like the idea is the hope that we're there to help coach, like the guide on the side in that pool analogy, with the students to engage in the inquiry and then give the teacher enough resources and supports to continue and take it further in their own class. I just linked as well in the chat, I know someone mentioned earlier they had joined sort of partway through. So the link to the resource links is in the chat again, and there's a list of resources that we've shared. I'm just going to post as well. We have a feedback survey that we'd love to hear from you. I think as Simon mentioned earlier, the way that we've delivered this program to you today is a little bit different. So we're really excited to hear your feedback around this mode of Science Center professional learning. And if you have questions, feel free to add them to the chat. If you have any follow-up questions from the stuff that we've shared today, Tasha, Martin, Simon, or I are happy to share any ideas based on your questions.
And it is an inquiry process ourselves in developing these programs. So we take these programs and we use the inquiry process here too. Change one thing and continue moving on and test it out. So this is a little bit of a test, but we love to hear your feedback. And then also we would love to, if you have any questions, please email us at scienceathome@ontariosciencecenter.ca. We would love to hear some questions, or even if you've done some of these experiments or some inquiry processes that you have done in class or you think are going to be very successful, share those with us, and we would love to see how you utilize this structure and this process in your own teaching too.
Thank you so much.
Thank you very much, and I hope you all have a fantastic day, and thank you for joining us at the Ontario Science Centre.
Thank you.
Thank you.